This meeting is being recorded.
So in the first few chapters of our textbook, we've seen some different representations of compounds. So we're going to introduce one more today. We're going to introduce these Newman projections and see why they're useful. So we've looked at everything from condensed molecular formulas to bond line structures, and then our wedge and dash notation to show the three-dimensional shape of a compound. So imagine we take a wedge and dash structure here and we rotate it about 45 degrees. So we're going to rotate this slightly to the right here. We could generate what's called this sawhorse. The sawhorse representation of the same compound. So this is ethane, right? In our first wedge and dash, right? We have our carbons here and here. 3 hydrogens are coming out. So again, we do that about approximately a 45-degree rotation here. And then we get this sawhorse. So we see our front carbon, now it's coming out towards us, and one is in the back, the start of this. So then we do another slight rotation here. So after about from start to finish about a 90-degree rotation, then we would have our front carbon here with those 3 red hydrogens, and then the circle in the back indicates our back carbon with those 3 hydrogens. So why do we need this other type of 3D representation? So these are the best way or ideal to compare the stability of different conformations. So we can have conformers or different conformations of the same structure. So it will not be an isomer, but due to that free bond rotation on our single bonds that we've looked at recently, we know that this bond in the middle here of our ethane can freely rotate, and that would move these hydrogens around, right? So these red hydrogens could all be rotated a little, so then they would block the blue hydrogens, for example. So let's try to imagine, this is that sawhorse form from our Newman diagram over here. So we have our front carbon over here that we are looking at. So this is our line of sight. And then to correlate that with the Newman projection, that's right here. And then our back carbon, the circle carbon, is this dot right here. All right, so as we're looking at that, looking down that carbon-carbon bond, this is what we would see, right? This Newman projection. And in this form, all of the hydrogens are staggered, or none are on top of one another. None are blocking one another. So that is one conformation where all these hydrogens are spread out as far as they can go. So let's look at this structure here. So we're going to start with this carbon here and this carbon here. So this is the bond that we're looking down. So this carbon in front has 2 hydrogens and a methyl group. So that's what we see here represented between these 3 groups on our front hydrogen. And then on the back, we see a chlorine, right? So that's up here on our back hydrogen, our back carbon, and then we also have a hydrogen, of course, that's here. And then we have another methyl group down here. So this is, again, another example. You just have to pick your line of sight and then determine what's the first carbon you're going to see. That's going to be your front carbon. And then you place your back carbon, the second carbon that you would see on that circle in the back.